Welcome back, everybody. In this video, we're going to learn about how to solve inequalities. Let's get started. To be clear, an inequality is any mathematical statement that uses one of these four symbols: less than or equal to, greater than or equal to. And there are a couple of nice properties of these guys that allow us to solve them. First of all, let's suppose A is less than B. I can add or subtract the same number to both sides of an inequality without affecting the solution set. That's what property A is saying. I can also multiply and divide numbers on both sides with an extra step. If the number is positive, no sweat. If it's negative, I actually have to flip the inequality around. Notice in part B, C, the number I'm multiplying both sides by, is positive, so I don't mess with the sign. But in property C, when I multiply on both sides, when C is negative, then I have to flip the sign around. This is true for all of the inequalities, by the way. This isn't an exclusive property to less than. The set of all values that make an inequality hold true is called its solution set. Let's find the solution set to this first problem. 3x minus 7 is greater than or equal to 13. The process for solving inequalities is exactly the same as for solving equations. I want to isolate my variable. The only thing I have to keep track of, though, are those properties up above. In this first problem, it's not going to be too much of an issue, because remember, adding or subtracting, multiplying or dividing by positive numbers all work exactly the same way as they do in equations. So my first step here is to add 7 to both sides. And then I will be left over with 3x is greater than or equal to 20. Now I simply divide both sides by 3. Since 3 is positive, I don't have to do anything to the inequality, and I just get that x is greater than or equal to 20 over 3. So all x values that are greater than or equal to 20 over 3 are part of the solution set. To represent the solution set, and this is going to happen in your homework as well, we often need to write our answer in interval notation. So this is all numbers from 20 over 3 onward forever and ever, and it includes 20 over 3. Remember, anytime an infinity shows up in our interval notation, we use parentheses. So this would be the solution set. Go ahead and pause the video here, see if you can try the next problem on your own. The solution set is negative infinity to negative 4, including negative 4. To solve, I had to divide both sides by negative 9, but that's a negative number, so I need to flip my inequality around from greater than or equal to less than or equal to. And that leaves me over with all x values that are less than or equal to negative 4. I represent that in interval notation with the answer in the box. Go ahead and pause the video here to see if you can try the next problem on your own. This one has almost the same solution set as the previous problem, except this time I'm not including the negative 4. How did we get there? The first thing I did was I distributed the negative 4 on the left-hand side. Then I moved the negative 4x over to the right side and the positive 20 over to the left side, and that left me with negative 28 is greater than 7x. Dividing by 7, I don't have to flip that inequality around, and I'm left with negative 4 is greater than x. Or maybe a more intuitive way to write that same statement is x is less than negative 4. That said, negative infinity to negative 4, including neither of those, is the solution set to this problem. Go ahead and pause the video here and see if you can give the next one a try. The solution set is negative 10 to infinity, including negative 10. The way that I got that was by first clearing the fractions. I saw I had x over 4, so I multiplied both sides of the equation by 4, which is a positive number, meaning I don't have to flip the inequality. That actually cleared all of the fractions simultaneously for me, and left me with x minus 6 is less than or equal to 2x plus 4. I moved the x from the left to the right side, I moved the 4 from the right to the left side, and that left me with negative 10 is less than or equal to x. Or, more intuitively, x is greater than or equal to negative 10. That gives me the solution set in the box. The next problem, however, looks a little strange, because I've got almost this double inequality, where I've got stuff going on both ends. The way to tackle this problem is by respecting all of the rules we've looked at for regular inequalities, how I can do things to both sides of the equation, but replace the word both in that sentence with all. For example, I want to isolate the x that's in the middle. So the way that I do that is I want to subtract the 3, right? But if I subtract the 3 from one side, I have to subtract 3 from all sides, not just one of them. On the left side, that's going to leave me with 3. In the middle, that's going to leave me with x. And on the right, that's going to leave me with 5. So x should be between 3 and 5, including neither of them. The way that I would write that solution in interval notation is parentheses, 3, 5, close parentheses. In the next problem, we have an absolute value showing up. Remember, when I have absolute values, I have two cases to consider. Pause the video here, see if you can tackle it on your own. The solution set is negative 22 over 3 to 4, including neither. The way that I got that answer was first by respecting the absolute value. I wrote one equation for the case that the thing in the absolute value is positive, that's the one on the left, and the other for the case that I have to change the sign, that's on the right. The left equation gave me that x should be less than 4, but the right equation gave me x should be greater than negative 22 over 3. And you may have thought to yourself, so which is it? Well, the answer is both. It has to respect both of those things for the left-hand side to be less than 17. So the numbers that are simultaneously less than 4 and greater than negative 22 over 3 are the numbers between those two. Using that same idea, go ahead and pause the video here, see if you can try this problem on your own. The solution set are all numbers less than or equal to negative 5 and all numbers greater than or equal to 3. When I split this up into the two pieces, the left equation, that's when I don't do anything to the absolute value piece, gives us x should be greater than or equal to 3. And when I look at the negative piece, that gives me that x is less than or equal to negative 5. Remember, it's both of these that make the equation true. In this video, we learned how to solve inequalities. Typically, we just use all the same tricks that we've already learned for equations, just being sure to flip that inequality if we multiply or divide both sides by a negative number. Catch y'all on the next one.